Right. Hello, everyone. My name is Silvia Ďurišová. I'm a first-year PhD student at the Slovak Academy of Sciences and the Comenius University. And I would like to share a few of my results from my diploma thesis, on which I worked under the supervision of curator. So what I wanted to do was to take a look at the few years from the EDMOND database. And I wanted to select a particular identification method of the meteor showers, see if I could replicate it, maybe even slightly modify it, and see what the results I would get. So I decided to use the independent identification method as was introduced by Rudavská et al. And this method consists of 3 steps. In first one, you grow the database and create very few groups of very similar orbits. In the second step, you merge this group into the clusters, and in the step 3, you compare those with the catalog of meteor showers. So the first group, the group is created by comparing the reference orbit with all the other orbits in the database based on the similarity function or D criterion, and of course the group then is excluded and its weighted mean of parameters is calculated, and the step is repeated until you run through the whole database. In the next step, you merge the group based again on the similarity function to create clusters. Then there is a few sub-steps where you check the clusters, maybe remove the meteors based again on the conditions you set, correct the weighted means, and the whole step is repeated a few times. And the first step, the identification is done. I compared the clusters with the official database, the Meteor data center. And the similarity function I decided to use in the steps. In the first step, it's the Southern and Hawkins criterion with a very strict threshold value, 0.05. In the second step, it was the geocentric similarity function, again introduced by Rudavská et al. With the value 0.17. And in the first step, there was a combination of a Jopek criterion, which is a modification of Southern and Hawkins with the threshold value of 0.13, and again geocentric similarity function. The threshold value for geocentric similarity function, I decided to use 0.17 based on the calibration to northern and southern Taurids. Visually, we can see that the radians are clearly recognized by using this threshold value. And now to the data. I decided to use the years 2014 to 2016, and Rudavská et al. Used 2001 and 2014, and they actually removed all of the hyperbolic orbits, but I decided to leave those with the eccentricity below 1.1. These orbits were left here because I do not suppose those are real hyperbolic orbits, but they are caused by errors, and probably many of them belong to the meteor shower. So to the results, 517 meteor shower I identified from the Meteor data center. I only counted those which had more than 20 meteors. Rudavská et al. Identified 296 to comparison. The difference between those numbers are, of course, due to our slightly modified methods. Besides the used die criterion, I even changed a little bit the identification in step 3. And of course, we need to take into account that since 2015, the MDC grew a bit, so there are more meteor showers there. There one when the schedule did their work. And of course, we work with with only 3 years, while they took into account the wider time range, but our years were more numerous in number of observations. And there were actually 45 meteor showers from work done by Rudolf Skydal, which I couldn't identify. Between them, 2 were established and 8 are already removed from the list. But overall, 30 from these showers had a number of meteors less than 20, which I did not even consider such groups. One of the examples where the identification method doesn't really work all that well is coma-Berenices. There is a clear group of meteors which seem to, when we look at the radiance in the elliptical coordinates and at the sporadic background, it seems to be the infiltrators from the apex sporadic source. Particularly, I want to look at the hyperlyrics. There is actually 10% of the meteors in the hyperlyrics which have hyperbolic orbits, and those are of course errors. Those 10% doesn't look to affect the calculated mean parameters, but let's take a closer look. On the graph on the right, this was taken from the work done by Hajdukova. These are particular meteor showers from the Japanese TV catalog, and we see the dependency of the number of hyperbolic orbits and the mean heliocentric velocity of the shower. So I did something similar, and there was actually 366 meteor showers that I found which had at least 1 hyperbolic orbit. So of course all of those orbits would be errors, and as we near to the parabolic limit, we see that the number of those hyperbolic orbits increase. The color codes on the graph on the left are based on the overall number of meteors in the shower. To take a closer look, especially alpha monoceratids, those are very close to the limit, and actually one of the mean parameters, eccentricity, was calculated to be more than 1.0, which would indicate the hyperbolicity of the stream, which is definitely not the case. There is only 35% of the meteors hyperbolic. Another one is, for example, December row Gemini, so those are pretty close to the limits. And to take even closer look, there's actually most of those meteors only tends to hundreds of meteors in the particle shower, but for example, signal hydrids, those are over 1,000 meteors overall in the shower, and about 16–17% of them are hyperbolic. So the next thing I wanted to look at is to take my calculated mean parameters of the meteor showers and compare it with the comets to search for potential parent bodies. Of course, those are only suggestion, which needs to be investigated further. Some of them confirmed those already in the MDC catalog. Some of them weren't there, and some of them actually had different parent bodies identified, and some couldn't be a viable solution, so those need to be investigated further. So I would like to thank my benefactors and thank you for your attention. If you have any questions, I will be happy to answer them.